Hello, everyone. I hope your days are going well. My name is Jack Stelly, and I'm here to review with you my study into the hydrological impacts dam operations are having in the lower Mekong region. The Mekong River, located in Southeast Asia, begins in the Tibetan Plateau, flows through China and into the lower Mekong region, which consists of Laos, Cambodia, Thailand, and Vietnam. 5 hydrological monitoring stations were utilized in this study, beginning with Cheongshan, which marks the northernmost boundary of this region. And continuing downstream, we have Luang Prabang, Mukdahan, Paksay, and Stung Treng. This river, more than anything else, is defined by its fluctuation between wet season and dry season. During dry season, the region sees low precipitation and high temperatures, and during wet season, the discharge rates of the river swell to roughly 600% of that during dry season. Ecologically speaking, this is the basis of all things in the Mekong region. Most notably, the Tonle Sap floodplain, located downstream of that Stung Treng station, relies on the annual flood pulse to flow through its river into its lake and create a large floodplain, which consists of temporarily inundated land to allow for rich vegetation growth and the migration and spawning of a vast number of species of fish. This vegetation and this fish population support both the riparian food security and the regional economy, being the exports of this region being primarily fishery and agricultural yield. Dam operations, however, are a bit at odds with this seasonality. To maintain peak efficiency, water is withheld during wet season and released during dry season. The ecological implications of this we will get into later. The presence of these dams was a bit different in the region than it was globally. From 1960 to 1991, there were no dams placed on the Mekong mainstream. And this constitutes our pre-dam period of this study. In 1992, the first dam is built, and this begins our transition period until 2009. And during this time, the production is fairly steady, and the expansion is primarily seen in the upper Mekong region. In 2010, the first megadam is built, and so this begins our megadam period. 2014 sees the production of a second megadam, and together these two dams, both located in the upper Mekong region, constitute 60% of the total basin storage capacity. And so these are very, very major productions, and the ecological implications of this are clearly seen at Cheongshan. And as we shift our attention to the right side of this presentation, we'll go through each station and the hydrological alterations that we see. So at Cheongshan, we are essentially representing the cumulative impact of upper Mekong region dams on the Mekong River. So as you see, the pre-dam flood peak seen in August is higher than the transition, and between transition and megadam periods, there is an even more significant decrease in that wet season maximum. As you can also see, the dry season minimum is increasing from the pre-dam to transition, and even more so to the megadam. Now, Cheongshan is the most markedly different seasonal cycle that we see across these 5 stations. However, as we move down to Luang Prabang, a similar trend is seen, and it substantiates our initial claim that these impacts of dam operations do indeed propagate downstream. Further downstream, however, at Mukdahan and Paksay, the river shows its ability to naturally restabilize itself, through local water cycles, precipitation, tributary flows. Flow accumulation is able to cancel out the impact of dams during wet season. The dry season flow, the dry season minimum, does see an increase there, but it's a bit more minor than that of Luang Prabang and Cheongshan. And just to further hammer home that flow accumulation, you can see the bottom graphics here. There's consistent y-axis across all stations here, and can obviously see Cheongshan is much, much more minor flow than that of Stung Treng, and even Mukdahan and Paksay. And so moving to that Stung Treng station, that final station, we do notice a kind of similar decrease in wet season maximum as we do at Cheongshan and Luang Prabang. However, these results are not because of upper Mekong region dams, or at least we are assuming this is our theory. It is more likely that the dams to the east of the Stung Treng station, located on the 3S River system, are more responsible for this hydrological alteration. And these changes seen at Stung Treng hold extra ecological weight because it is so close to that Tonle Sap floodplain. And trends at the Tonle Sap floodplain of inundated land are kind of the other aspect of this study. Over the past number of decades, the Tonle Sap floodplain has seen an increase in permanently inundated land. So essentially the lake has grown, and it has also seen a decrease in temporarily inundated land. So essentially the floodplain has shrunk. And so the final conclusion of this is that dam operations are having a direct impact on the Tonle Sap floodplain, and it is kind of reducing that functionality of the floodplain. As of 2019, 89 dams were located in the lower Mekong region with a total energy production of 12,000 megawatts. By 2040, 44 more dams are planned to be implemented, and the total energy production is seen to increase not by 30,000, but to 30,000 megawatts, in addition to the 10,000 megawatts that look to be expanded in the upper Mekong region. The ecological implications are not quantified in this study, but based on historical trends and literature review, this study does emphasize that the threat could both be catastrophic and permanent. However, this is still unclear. We do not call for the abandonment of hydroelectric energy, far from it. The presence of this is undeniable in the region. Mekong's capability of doing so is proven. However, emphasis must be placed on the balancing of economic development and ecological sustainability. And that is the main point of this paper. Balancing the development and food, water, energy progression of this region with the sanctity that really holds it all together. Thank you so much to the INSURE program and the National Science Foundation for this opportunity, and thank you to all of you for taking the time to hear me speak. Thank you so much, and have a great day.